Welcome. Thank you very much. It's so great to see all of you here. My name is Waleed Kadous, and with me is Jaikumar Ganesh. We're the tech leads on the Android location team. And we're super excited today to be sharing with you some of the new features for location we've added to Android. This is probably the biggest change in location since Android was released. And we wanted to walk you through some of the changes that we have planned. So let's get down to the specifics. What's changed? We really want to talk a little bit about what's changed that made us want to make these modifications to location on Android. And there's two major sets of changes. One is the prominence of new types of apps, and then the other one is some of the underlying technology for location has also evolved. And we're going to walk you through those. Then we're going to talk about some of the technologies we've added that were mentioned in the keynote yesterday. The fused location provider, the geofencer, activity recognition. And we're going to take you behind the curtain, show you how we built those things and how they work. And we might even have some live demos so there's the potential for us to crash and burn. And then finally after that, we're going to have the opportunity to look ahead and to really see what the potential of some of these new location APIs are. So let's dive right in. One of the changes is the growing importance of location. So a lot of the most popular apps now, if you go to the App Store, they're using location. And a huge number of applications across the board are using location. You know, Google Maps, G+, Facebook, Twitter, Google Now, all of the really prominent applications. And we really wanted to have the opportunity to improve the quality of those three things. So when I say quality with respect to location, it means three things. And we're going to keep coming back to them. Power, accuracy, coverage. Not just that, but there's this new type of app that's coming around that we're calling contextual applications. Those are the things that Larry and Amit were talking about, the Star Trek computer at the keynote yesterday. Phones that are smarter, things that we can use to make the phone smarter so that the user can get on with their lives and those annoying, tedious things can just disappear. How we can make, as Rito said, our applications more magical. So one example of that contextual app is Google Now. Who here uses Google Now? And how do you like it? Yeah. And so that for us is an example of an awesome contextual app. But let's do a deep dive for a second and see how central location is to that app. So we took all of the cards that were in Google Now. The team from Google Now is just awesome. They keep adding cards. But we did a survey. And remember, Google Now is meant to be a contextual app for all types of context. But the thing that you realize very quickly is a huge fraction of the cards that Google Now makes available rely intrinsically, deeply on location. And we think this is true of many contextual apps. If you want to build the Star Trek computer, how can you do that without knowing where you are on the Starship Enterprise? That's the thing that we're trying to say. So if you really want to build world-class contextual apps, you need to have high-quality location. But here's the issue, and this is why we introduced some of those changes. It's because the requirements of contextual apps like Google Now are a little bit different to apps like Google Maps. So if you look on the left-hand side, you have Google Maps. Think about how you use this. You use Google Maps when you need information right now. It's task-oriented. You open Google Maps, and then you try to accomplish something. It's very different to Google Now. Google Now sometimes will notify you, and sometimes you'll just pull it out and expect it to have something there waiting, ready for you to go. The usage model is different, and the requirements for location are different. So for instance, let's look at one aspect, which is power. So if you're running Google Maps, here are some power numbers. And I know that power is really intrinsic to these questions of location. When the screen is on, it's pulling about 350 milliwatts. When the processor is on, it's pulling about 300 milliwatts. By comparison, GPS is pulling 100 milliwatts. So that means that GPS is consuming somewhere in the realm of only 14% of the power when you have the screen on and when you're looking at a map. But if you have something like Google Now, if you were pulling 100 milliwatts, you would flatten the battery so quick your users would just dump your app right then and there. So you have to be very careful with power, and the requirements of contextual apps are very different. And you'll see that going through what we do. So another example is accuracy. You don't always need super duper accuracy for something like Google Now. Whereas for Google Maps, if you're indoor, you want to know exactly where you are. So I talked a little bit about the changes to the applications that we might want to develop, the growing prominence of location. I talked about, for example, contextual apps and their ability to add value. But there's also the technological changes. And that is that it's becoming very, very hard to really build high-quality location models for developers. And it's something you guys shouldn't worry about. It's something we should be worrying about while you focus on building great apps, right? And here's the issue. You have now, if you really want to build a high-quality app, you need to talk to 4 different components: GPS, Wi-Fi, cell, and sensors. And the thing is, each of them has different characteristics. So for instance, GPS, it's horrible on power. Like I said, about 100 milliwatts. By comparison, Wi-Fi is about 30 milliwatts, about 1/3 of the power. But the thing is that the accuracy of GPS is really good. And Wi-Fi is, sometimes it's good, sometimes it's not quite so good, right? Coverage, on the other hand, GPS doesn't work indoors. And given how much time people spend indoors, that's just unacceptable. And as well as that, you have cell, which has great power, because it's basically free, but the accuracy is pretty bad. Think half-a-mile accuracy. And then there's this new kid on the block, sensors, which we'll come back to in a few moments. So let me again just explain a little bit what I mean by this problem of complexity. If you really want to build a high-quality app that meets those 3 characteristics we talked about, power, accuracy, and coverage, you've now got to deal with this mess across the OS. You've got the network location provider, the GPS location provider. You've got to talk to them. Then you might want to subscribe to the passive location provider, and then you also have to talk to the sensors. Developers shouldn't have to be thinking about all of those things when all they want is, I just want a location, right? Like, they shouldn't be thinking about these types of problems. And just to kind of hammer home the problem, this is a screenshot from our documentation for location right now. And you can see at the bottom here, there's this timeline that says, application starts, and then you get an update from the GPS, and then you get a cell location, and you have to maintain a best estimate. And anytime there's a timeline like this in the documentation, you know that the technology has evolved beyond the point where the old APIs worked really well, and you need to update your APIs. And that's what we've done. So I said that there was a couple of different technological changes. There's one particular one that I wanted to highlight, and that is the increasing importance of sensors. This last column here on the right. And they're kind of the new kid on the block as far as location's concerned. And I think some of you might be thinking, well, sensors, great. They're for games, right? But the thing is that sensors are actually amazingly powerful. So let's just take a few moments to discuss the sensors that are on some of the phones, in particular the accelerometer and the magnetometer, or the compass. They're on all the phones. But really good phones will have all 4 of these sensors: the accelerometer for horizontal and lateral movement, the gyro for rotational speeds, the compass and magnetometer for which way is north, and barometer for elevation. And you might be saying, well, I mean, think back to what we were talking about yesterday at the keynote. I mean, there's questions there about making our phones smarter, and these sensors are a really huge, important part of that. And I want to give you an example just about what we're talking about in location of 3 things we can do. We can use these sensors to save power. A lot of the time, people are just sitting still. If you're sitting here in this room with your phone in your pocket, why do we need to even try to calculate your location once we know what it was, right? We can check the accelerometer, and that will tell us about movement. We can also do things like detect the activity. So if someone is driving, we can check for location more frequently. If someone's sitting still, then we don't need to do that as often. And finally, it can have a huge impact on quality. And what I'm going to do now is I'm going to show you some of the data from our location, our indoor location. And that's really where sensors come into their own. So here we go. Right. Can folks see this? It's OK? Good. All right, so here's what happens. Over here, you have the green dot. The green dot is ground truth. This is the Bloomingdale's just behind the center here. So behind Moscone, you can actually go visit this venue. I think this is level 3. Green is ground truth, that a member of the Google team went and collected this data. And yellow is our best estimate once we mix Wi-Fi and all of the other sensors together to give a good estimate. And you can see it's not exactly perfect. It's just going to start animating now in a moment, hopefully. Yeah, there we go. And you can see that as the green dot moves around, the yellow dot does a pretty good job, not always, of following around the green dot. It doesn't jump radically. It doesn't move around. As you can see over there, it's like following just ever so slightly behind. And And you can see that that's where we use the sensors to really get that smooth, high-quality result. Now, one of the key inputs to indoor location is the Wi-Fi. But I wanted to show you how bad just the Wi-Fi by itself was. So I want you to see how much the Wi-Fi jumps around. And we talked about this a little bit before. Watch this. It just jumps to the other side of the building. You know, someone got between. Again, it's just jumping all over the place. But by using the sensors on the phone, we're able to smooth this out and give a really good prediction of where the user is. Let's go back to the presentation now. There we go. All right. So our goals in this effort of introducing these new features was really along these lines. First of all, we've got to get the power down. We hear you loud and clear. Location takes too much power. But it's so critical to contextual apps that we had to fix this problem. The second is we wanted to get that accuracy up and that coverage up so that you could use it indoors and we could have like higher accuracy. And we also heard from developers that location was just too hard to use. So we wanted to really make it easier for you guys. And we can also do things like optimize more efficiently across the OS by looking at all of the different location requests. We also wanted to show you some of the awesome new things you can do with sensors. And most importantly, we wanted to make it available on as many Android devices as possible. Millions are just not good enough. We need hundreds of millions of devices that can use this API. And with that, I'd like to hand over to my colleague, Jaikumar, to walk us through these changes.
So the first thing we want to talk about today is the fuse location provider. We want to move from this, where the developer has to take care of the sensor manager, the GPS location provider, the network location provider, a location manager, to this, where the developer doesn't have to worry about individual platform and hardware components. So simplifying our APIs here was our main goal. But then you might say, hey, we are engineers. We really want to understand what's happening under the hood. To help you explain what's happening under the hood, we have a bunch of videos. In this video, the green dot represents the actual location, and the yellow dot here represents the GPS location. You'll see that GPS tracks the location pretty well when the person is outside, but as soon as the person has entered the building, GPS basically has dropped dead at the door. The person is now going through the various corridors, and we have completely lost track of the location. Exits the building, and you see that GPS puts you right in the middle of the parking lot. See the big jump from the door to the parking lot. The person had not even reached the parking lot. This is a Google building, and this is actually one of our Google team members collecting the data. Waleed just mentioned about Wi-Fi. So how does Wi-Fi compare to the actual location? Again, green is the actual location. Red is the Wi-Fi location. It's basically useless when you're outside. Indoors seems OK. Bit jumpy. User is navigating the corridors. It's OK. But then when the user transitions from indoors to outdoors, you will see that we have kind of lost track of the location again. So what did we do? We took cell, Wi-Fi, GPS, and sensors and fused them together. So let's see how the fuse location looks. If there's one slide you want to take home, this will give you a very good indication of what it is. The blue dot represents the fuse location, green dot the actual location. Following very well when the person is outside. Continues following the actual location when the person is inside navigating through all the corridors. This user looks drunk. The exit is that way. There you go. And now notice the transition from indoor to outdoor will be much more smoother than when we were using GPS. The GPS put you in the middle of the parking lot. This one is much more smoother. All right, so let's have a closer look at the APIs. Before that, I wanted to talk about two things: listeners and pending intents. Most of you are familiar with the register listener call. Your app registers a listener. The location process will give you a synchronous callback via the binder mechanism. That works very well if you are in the foreground. You're a maps application, navigational application. But there's this new class of applications that we just talked about with all the contextual apps that want to run in the background. So you don't have to be, your process doesn't have to be tightly bound to the location process. This is where pending intents come into play. So what's a pending intent? It's a token that your app process will give to the location process, and the location process will use it to wake up your app when an event of interest happens. So this basically means that your app in the background doesn't have to be always running. When something of interest happens, we will wake you up. This saves a lot of battery. All right, so now that I've talked about pending intents and listeners, let's have a closer look at the APIs. You create an instance of the location client. You call connect on it. You get a callback on connected. You call the function get last location on the location client object. You will immediately receive a course location that's maintained by the system. The second variant is creating a location request object. You set the priority. You set the polling interval of the location. And the function that you would call is request location updates. You send in the location request object. You send in the listener. And we will call your callback on location changed so that you will get the latest location. That's it. Just this one API will give you the blue dot that you just recently saw in the animation. So that's how it worked with listeners. What about the pending intent variant? You create an intent, pending intent, by calling get service, call request location updates. Again, the very same function call. Takes in the location request object, sends in the pending intent. You will get a callback with the location object. Same API, both use cases. So I introduced two variants of the APIs, get last location and location request objects. When would you use them? So get last location gives you a course location that is maintained by the system immediately. So suppose you are a search application that's searching for movies or a weather application, and you just want the user's city. Get last location is for you. But if you're a maps application or a navigational application, and you want finer grain control, you want to set the interval, the priorities, et cetera, and that's when you use the location request APIs. I mentioned priority twice. So what exactly are these? So for the location request APIs, we are providing you with 3 options for priorities: the high accuracy mode, the balance power mode, and the no power mode. The high accuracy mode corresponds to GPS when you're outside and cell and Wi-Fi when you're inside. It is basically useful for map applications like maps and navigational applications, which want really good accuracy. Because they are running in the foreground, the battery drain is fine. And the typical polling interval is around 5 seconds. The balance power doesn't use GPS. It uses cell and Wi-Fi. It is fine with slightly lower accuracy, and it doesn't want to drain the battery that much. So if you're a weather app, this is when you use the balance power. The typical polling interval is around 20 seconds. We have a third mode called the no power mode. The no power mode is useful when you just want to get a location if some other app in the system has requested the location. And you don't want to actively poll, but if the system knows the location, very well, I can enhance my app. So that's when you use the no power mode, and this is the best part. Your app will not get any battery blame. A caveat about the accuracy. Accuracy basically depends on various parameters, the signal quality, et cetera. This is a rough guidance with regard to the 3 priority options. All right, so next topic, geofencing. What's a geofence? It's a virtual fence around an area so that when the user enters or exits the area, the app is informed. So you can have a geofence around a Starbucks location. And so when the user enters the Starbucks location, your app would inform, and say, for example, it can give you offers that the user has entered the Starbucks location. We have 2 demos for you.
Yay.
So we are in the middle of a lecture hall here. So we have this mock sample app, which basically mocks the location waypoints. So let me start that. And this is me driving through Mountain View, and we have 2 geofences. I'm a very cautious driver following speed limits, so I have to follow the rules, so I don't want tickets. There you go. And the user has entered the first geofence. You can see that the app has got the geofence entering result and has put the black border. This app is currently showing 2 geofences. We support multiple geofences.
Wait a second. How many geofences do we support, Jaikumar?
Good point. So we have heard you guys. We support 100 geofences per app. That is a big number, and we feel that you will be able to accomplish a lot of things that we feel that you'll be able to accomplish a lot of things that you weren't able to do before. The user entered the second geofence, and I hope you saw the circle getting highlighted. I live in San Francisco. I like the city life. But my office is in Mountain View. Commute can be hectic. So I've been thinking of...
I want to make him work harder, so I want him to move to Mountain View.
So the commute can be actually a bit hectic. So I use this app called Zillow. It shows me a bunch of all the open homes, the homes pending for sale, etc. So 2 weeks back, I listed one such home as a favorite home. Zillow app shows me all the photos, descriptions of what kind of the sale price, etc. So this was 2 weeks back. Just yesterday, I was driving through Mountain View. So let's start our location mock app again. So the user is again driving through Mountain View, and I see this notification on top that Zillow has put. It tells me that there was a favorite home nearby. There you go. And I can actually see all the photos and details of the favorite home. This was the same favorite home I marked as a favorite 2 weeks back. We were just now talking about contextual apps. Zillow used my context, my location, and showed me a reminder, hey, this home that you marked as favorite 2 weeks back is just a mile away from you. Why don't you go and have a look at it? This is the power of geofencing. It allows such contextual apps to be so powerful. All right, so let's look at the APIs. You create a location client object, call connect on it, just exactly the way you're doing for the Fuse location provider. You get an on-connected callback, and you create a new geofence object. You set the request ID, the transition types, whether you're interested in entering or exiting the building, the type of geofence. Currently, we support circular geofences, the latitude, longitude, radius, and the time when the geofence will expire. One API, add geofences, takes a list of geofences and a pending intent. When a geofence transition happens, you'll get a callback. You can check which geofence has been breached and what was the transition event. That's it. One API for addition, one API for removal, and you can build these powerful apps.
So how long did Zillow take to make the modifications?
So Zillow used our APIs, and they were up and running within a day. That's all they took. We said, hey, yeah, so we gave them our sample APIs just to make sure things work, and they had a demo build for us. Some of you might already be familiar with the Add Proximity Alert API in our platform, which does geofencing. So why did we introduce this new API? Let's compare the two. We ran a bunch of tests. One geofence around the home, one geofence around work, a bunch of geofences around the various Starbucks location. We ran these tests over a period of 24 hours on a Galaxy Nexus, and we saw a 2/3 power savings. 2/3 power savings. Sure, you can clap for it. Battery is important. And so, apart from power savings, the APIs are much more powerful. You can add multiple geofences. It tells you which geofence has been breached. You can set the various parameters associated with the geofence. So I just now told you we saved a lot of power. How did we do it? 3 ways. You are in San Francisco enjoying the Golden Gate Bridge, but you have a geofence in Hollywood, Los Angeles. The phone knows this. The phone doesn't have to keep polling to know whether you have entered the geofence or not. The user can be still. The user can be walking. The phone knows this. The phone can use this as a signal to configure its polling interval. We also want to move to doing things in hardware. Geofencing is basically a background process. That means that the application processor doesn't have to be always awake. We can do geofencing monitoring in the hardware, like the GPS hardware, and the hardware can tell us, hey, the user has entered the geofence. I just now talked about monitoring using user state and using it as a signal. So how did we do it? So let's talk about activity recognition. We can use the sensors on the phone. That's, after all, a smartphone. And we can figure out whether the user is driving, whether the user is on foot, whether the user is still, or whether the user is on a bike. So this is what the accelerometer data looks like when the user is walking and the user is in a car. So we used machine learning-based classifiers, bunch of training data, and we were able to actively figure out which class of activity the user is involved in. So where would you use this? We gave our APIs to a very popular third-party application, Endomondo, and these are 2 screenshots. They can give you details of how much time you have spent walking, how much time you have spent biking. They used our APIs, and yet again, they said, battery life is much, much better. So let's talk about another application, the Moves app.
Wait a second. There we go.
So Moves app is a third-party activity tracker app which automatically detects your activity. The user just keeps the phone in the pocket, walks around, and they can detect whether you're cycling, driving, running, etc. So let's open the app. This is what the app looks like. It tells me how many steps I've taken today, how many miles I've biked today. They have this beautiful timeline. Let me go to yesterday. And they have this entire timeline of what I did yesterday. I went to Washington Square, was in Moscone, Starbucks. I biked to Moscone West, so let me click on it. And if the network connection works, you will see it nicely superimposed on a map. But let's raise the bar up here a bit. How about a live demo?
Video.
Let's invite Mark on stage. Mark is the engineer who has done most of the work for activity recognition. He has a phone in his pocket, which is monitoring activity. And there's this tablet, which is basically listening for it. You can see that the phone is in tilting state, which basically means that the phone is about to change the activity. Mark has started to walk around the stage behind me, and you can see it's on foot. This is all lifetime, real-time networking from his phone in the pocket to this tablet. Mark is on a bike right now. The phone has gone to tilting, and there you go. It's on a bicycle. Mark did a really great job working out, biking every day. Let's get this working. Let's get this working. Thanks a lot, Mark.
Thanks a lot.
Switch. All right. The demos look great, but how do you use it in your app? That's why we have this slide to have a closer look at the APIs. You create a new instance of the activity recognition client, call connect on it. When the callback comes, you get on connected. Again, just one API, request activity updates. 2 parameters, the detection time interval that basically says how often do you want to poll the system to get activity updates, and the pending intent. You get a callback. You can extract the activity and get the probability. So the detected activity is basically in vehicle, on bicycle, on foot, still and tilting. And we are going to get Mark back to the office to add more classes to this. All of these activities have associated probabilities. One important thing to note, this has a new permission, the activity recognition permission. So we talked about fuse location provider, activity recognition, and geofencing. So how can you get these? We are using the Google Play services to deliver these APIs to you. The Google Play services is an APK that gets updated from the Play Store, has two parts, the client library that your app links against, and the Play services APK process. The client library is intelligent enough that it knows to handle older and the newer versions so that you don't have to take care of it. Here's the best part. The latest APK with all these APIs is already pushed out, is already there on the phones. The documentation is already ready. So you, in fact, can go start coding right after this session, and you can push your app today evening, and it will be live. That's to borrow a word from the keynote, that's what we call it as auto awesome. So we moved to Google Play services. Why did we do that? 3 reasons. One is that it's backward compatible to Froyo, so it gives us hundreds of millions of devices for free. The second reason is that we have a bunch of indoor floor plans, indoor data models. So we have the potential of using these floor plans and data models to enhance the APIs, to add more context, to add more features so that all the indoor features work very well. The third main reason is the shorter release cycle. You discover a bug, you tell us. We want to add a new class for activity recognition. We can do it much, much faster than waiting for the platform updates. So with that, I would like to welcome back Waleed on stage to talk about what's next.
Thank you very much, Jaikumar. Thank you very much, Jaikumar. We really appreciate that. So I wanted to talk about the improvements. And you're going to see it's the same patterns: accuracy, power, coverage. And the question is, how are we going to do that? And we wanted to share with you some of the ideas and some of the upcoming technologies that are coming through. One is improving accuracy. So before we mentioned that there were 4 sensors, cell, Wi-Fi, GPS sensors, one other one. But there's even more coming. So for example, Bluetooth Low Energy is coming. And that will allow us to get even more accurate location, especially indoors. There's even standards like 802.11v that takes humble Wi-Fi and gets rid of the jumpiness by adding time of flight. So there's all of these new technologies that are coming that are going to improve location even more. And we're really excited to be including them. And the nice thing is you don't have to modify your app. We'll just add those extra columns to our list of 4 things. We'll do all the hard work for you. That's another reason. The other thing is we can do more intelligent things with, say, using indoor floor plans to improve the accuracy. Not only that, as Jaikumar mentioned when he was talking about geofencing, we can do a lot of this on the hardware. And we're already working with hardware vendors to really improve the standards and improve things like the hardware abstraction layer for sensors. And if any of you are interested any of you are hardware developers and you're interested in that, please come talk to us afterwards. And the progress so far on that has been pretty amazing. The other thing is better coverage. We really want to get indoors. If you're going to build contextual apps, you need location that works all of the time. And that's why, as part of our efforts, we're expanding our indoor coverage, because people spend so much time indoors. So thank you very much for your attention today. There's a few things I really want you to take away from today's discussion. Our obsession, my motto and the team's motto is power, accuracy, coverage. Those are the mottos. My personal motto is 1 centimeter location, everywhere, always, and that's what we're going to continue to strive towards. As well as that, we want to make your lives easier. We want to do the hard, heavy lifting for location so that you guys don't have to. So we're trying to make these cool, these new, nice interfaces like the Fuse Location Provider for you. And also, we just want to add some cool stuff like activity recognition. We've mentioned the APIs before. The Fuse Location Provider gives you simplicity, lower power, more accuracy. We talked about geofencing and activity recognition. And personally, activity recognition, that's what I want to see you guys just explore what's possible, because it's never really been available before. And yet it's this sensor that's on the phone that allows us to improve the context. All of these features are available today in Google Play services on hundreds of millions of devices. And we're going to keep adding features. We're going to add other types of geofences other than circular ones. We're going to look at integrating things like semantic information about place. We're going to do things like add higher level activities. All of these things are possible. And we'd love to hear from you more about these things as we go forward.
So Waleed, I guess you have to mention that we are wanting to do the hard work here. You guys should just think about apps and UI, and we do the hard work for you.
As far as location's concerned anyway. We can't do everything for you. So here's my parting question. You heard Amit and Larry talk about smarter phones. You heard them talk about Star Trek computers. At the heart of context are things like these sensors that we mentioned, are things like location. And what we really want to see you do is, what apps can you build that make your users' lives easier using location and activity to just make your apps get to that next level higher, to make them magic like Rito was talking about in the previous session. Thank you very much. There's a few quick notices here. So we have a code lab tomorrow in room 9, 11:15, where we'll be walking you through making some of these changes. There's the feedback counters at the end, and we'll be at office hours to answer your questions about location immediately after this. Thank you very much. We look forward to your questions. Please come to the mics. Any questions?
Sure.
Come to the mic, please. We have time for maybe one or two.
You mentioned there was support for 100 geofences. Was that per app installation or overall for an app?
100 geofences per app. You shouldn't have to think about what other applications are doing, right?
No, but I mean, if your app has multiple users, each of those users has 100 geofences available?
I think so. It's per app per user. We can double check.
Yeah, we can double check this, yeah.
Thank you. That's important for us.
OK, next question.
Hi, this is Alex Jimenez. I just wanted to ask you, you mentioned something about you can also do this on devices other than the phones. Is this going to be also part of the ADK?
We're still exploring that option. We don't have an answer right now.
Okay.
But stay tuned to see what we come up with.
All right, perfect.
Cool.
Thank you.
One last question.
This is probably a product of the training data, but I was wondering if you took into account things like a user's on a bike and maybe they have their phone in their backpack and you're not getting quite the tilting and twisting data from the sensors. Does it still recognize situations like that?
We've tested along many different types of situations. Because of the machine learning, and we've gathered data in those situations, it actually pretty well adapts to those situations. It's not perfect, and sometimes it will report tilting. But by and large, it works pretty well. We've measured pretty high accuracy on it.
Do you also take into account like their current speed to say like, maybe 15 miles an hour is about like a biker's speed? You're not walking at 15 miles an hour, right?
I'm not sure we can double check that.
Okay.
Meet us at the office hours and we'll get into the details.
Sure.
I had a couple quick ones. Number one, what's the lag time between, like, if you switch activities from, let's say, walking to driving, what's the lag time between an app getting that kind of a registration?
It varies a little bit from what the transitions are, but think on the order of 30 seconds to a minute.
So just to give you an accurate figure, the live demo here, it took like 8 seconds from him to go to biking, from foot to bike, and in between we had the tilting to say that there is an activity change. So we have to, be careful about false positives and false negatives.
Sure. And do you happen to know, is there a way, given like the current driving activity, is there a way right now that you could tell if you're a driver or a passenger? Or is that something you might work on? Or
we can't do that right now. But who knows what the future holds.
All right, thank you.
All right. Thank you very much. We really appreciate your time today. Please come to the office hours and the code lab tomorrow.
Awesome.